In the ever-evolving world of football, there's a revolution quietly underway, transforming the way we understand the beautiful game. From the roar of the crowds to the precision of each pass, every aspect of football is now being dissected and analyzed with unprecedented depth and sophistication. At the forefront of this revolution is the concept of expected goals, or XG, a metric that has rapidly become the cornerstone of modern football analytics. But what exactly is XG and how has it reshaped the landscape of football statistics in such a short span of time? Are similar metrics like XGOT, XA, XGChain, XGBuildup, and expected threat equally significant? Join me, Ryan Field, as I delve into the intricate world of XG and its derivatives, exploring how these cutting-edge metrics are revolutionizing the way we perceive player performance, team tactics, and the very essence of the beautiful game. Football is becoming an intricate science by the year, and to catch up with it, especially if you're eager to analyze it on a deeper level or pursue it professionally, you need meticulous study of some of the game's in-depth modern analytical insights to gain competitive advantage in understanding the game at a profound level. When an art or sport, or anything for that matter, gets to the highest points humans can perform it, the smallest details become decisive. At its peak level, football is no exception. The whole thing is now way more complicated than what you see on your screens. Each group or individual movements of the players in a football match are carefully planned with specific names and specific tactics. We'll get to as many as we can through our series of technicality in this channel, but today we're focused on the most important statistical information in modern football: expected goals, or simply XG. Introduced in 2012 by statistical expert Sam Green from Analyst, expected goals has since become the most widespread and insightful metric within football analytics. According to the creators of this concept, XG measures the quality of a chance by calculating the likelihood that it will be scored by using information on similar shots in the past. So Analyst says that through machine learning, they have analyzed 5 million shots to measure XG on a scale between 0 and 1, where 0 represents a chance that is impossible to score, and 1 represents a chance that a player would be expected to score every single time. In the simplest terms, if you see a player at the end of a game with an XG of 1, it means that their chances have had the potential to score 1 goal. Did it turn out to be a goal? That's none of XG's business. People who have watched football for a while know that a higher score on the scoreboard does not always necessarily translate to a quality team performance. Some would say it would win it though, right? Surely it will. However, if you're planning for long-term growth and consistent success, you need a deeper analysis to know the true level of your team's quality, regardless of winning or losing a game or two. That's where XG comes in handy. This model uses several variables from before and up to the exact moment the shot was taken. It evaluates over 20 factors and affect the likelihood of a goal being scored, including distance, angle, goalkeeper possession, the clarity of the shooter, the amount of pressure they're under, shot type, pattern of play, and the information on the previous action, such as the type of assist. Situations such as penalty that are particularly unique would be modeled independently. Take the example of Alexis, Sanchez, and Ruben Neves, both with 63 shots in the 2022-2023 season. Sanchez scored 12 goals while Neves scored 3. By quantifying the quality of all those chances for each player, we would expect that from the chances Sanchez had, the average player should have scored about 10 goals. On the other hand, from Neves' chances, we would expect the average player to score only 3 goals. Both players overperformed slightly according to their expected goals output, but their 63 chances were very different in quality. This was an example on an individual player, but the expected goals metric can be used for teams or games as well. Here's a very important point. It may seem obvious to many that a player or team may score more or less often than their XG value suggests, but this is exactly the variance we can now analyze. Is a player scoring less than he should be? Who is getting chances from high XG situations? Which player can score from unlikely possessions? and how calculated are our goals versus those scored by chance. By the end of the game week 28 of 2023-2024 season of the English Premier League, Erling Haaland has scored 18 goals. One couldn't do a lot with the number alone in an in-depth analysis. However, when you find out that the XG for the player stands at 21.84, meaning it was expected of the player to score almost 22 goals, you figure out that the player has slightly underperformed considering the quality of the chances he's had. In another example, on a team level in the same period, Arsenal have an XG of 61.19 but have scored 70 goals, showing the overperformance achieved by its players in difficult goal-scoring situations. Keep in mind that the XG metric can be extremely useful in the analysis of a team's defensive mechanism as well. Teams can realistically measure the quality of their defense by assessing how much they have allowed the opponent to create real opportunities. XG on the player level is pretty straightforward, but on a team level you have to keep in mind that a team having a higher XG total in a match doesn't necessarily mean that they should have won the game. XG is only measuring chance quality and not the expected outcome of the game. As XG evolved, it expanded to metrics like the expected goal on target, expected assist, expected goal chain or XGChain, which allocates the total XG of a situation among all the players involved in that attack. XGBuildup, which attributes the XG value of the final shot to all the players involved in the entire possession before that goal. And a uniquely important one which is introduced very recently, expected threats, or XT. This is where it all feels like a mind-blowing calculus exam, but what I can do is to try to explain it as simply as I can, and what you can do is hit that subscribe button. Thank you. Expected threat parameter is super important and incredibly significant. Almost as important as XG or even more. Here's how it works. They divide the football pitch into so many zones, where each zone has a value assigned to it based on how likely a goal is to be scored from that zone. Then players can be credited for moving the ball from one zone to another. See what they did? They solved one of the most important problems in football. Haven't we all witnessed situations where you absolutely don't want to give the credit of a goal to the goal scorer? They just did a tap in. Sometimes you feel just a bit better to see that at least the person who contributed the most on that goal gets the credit for the assist. Yet there are countless instances where neither the scorer nor the assister have had the most contribution. Sometimes it's that pass just before the assist that matters the most. Sometimes it's not just a pass, it's the transition of the ball through a difficult path that creates the most value. If we fail to acknowledge this very essential contribution, we've come up with an incomplete analysis using superficial parameters like assists and goals, probably resulting in the wrong evaluation of our players. This is where the expected threat model comes in and saves the day for us. Now the player who has dribbled 3 opponents and broke the defensive line with a precision pass gets the XT value of moving the ball from a low-threatening position to a high-threatening zone. Let's wrap up the video with a clear XT example. Look at this Arsenal goal for instance. Ozil breaks the Burnley defense line with a brilliant pass and delivers the ball to Kolasinac, who plays a cutback to Aubameyang and he finishes it. He gets the goal, Kolasinac gets the assist, and Ozil gets nothing. Does it look fair? Or just forget fair? How accurate does it look? XG and XA can't help us here, as Ozil has neither scored the goal nor has he assisted it. XGChain can help us here, as it equally divides the XG value among all the players involved in this attempt. Enters the XT. This model divides the field into 192 almost square-shaped areas. In the area where Ozil receives the ball, the XT value is 0.077, as it's not a very valuable place. He sends the ball to an area with the XT value of 0.158, increasing the value of the ball possession by 0.081. If you repeat the same scenario for Kolasinac's pass, he's only added 0.013 expected threat to the ball. On a percentage level, we can now conclude that Kolasinac has helped create the goal 14%, while Ozil now stands at 86% contribution. he receives the accurate credit for the value he's added to the offensive process of this goal. In a world where football's evolution hinges on deeper statistical insights, XG and its derivatives add additional context that goes beyond the traditional metrics and help us through the complexities of the beautiful game. With each pass, each shot, and each goal meticulously analyzed, these metrics not only redefine how we perceive player performance and team tactics, but also offer a glimpse into the future of football analysis. As this sport continues to demand a deeper understanding, XG and all its derivatives emerge as the key unlocking new realms of the strategic brilliance and unparalleled excitement, shaping the way we experience and appreciate the game on a whole new level.